in 3D plane.
Okay, thank you. So I had just briefly talked about the 3D plane, which I said taking an example of a room. So a room has when you go in the extreme end of the corner. Maybe let me bring something here and then we can explain it a bit clearer. So we normally say that is the X. Then there will be another one going this way. Then we can have one going up. Okay, so if it is in this form, I guess all of us are able to see that.
Yes.
Yes, so this may form a 3D. So when we make it complete, so for example, if we again draw a line here up to there, so if we drew this and made it complete, it would make a 3D shape. So much as this here is not clear, but for illustration purposes, it can do. It can do well. Then we bring this one here. And then we draw another one up. So are you seeing how I'm forming a box? Much as it might be not be very accurate. Okay. So here, this would be a three-dimensional shape. So for example, a box. So that box has on every corner. So if we check on every corner, maybe somebody can describe. Can describe what they're able to see. So like especially at every corner. So what do we see at every corner? I'm seeing two people have typed in the chat. Yeah, you are welcome. Okay, at the edge. Yes, at the edge. So what are we able to see there? Peter, what are you able to see at every edge of this shape that is displayed?
Pardon?
What do you see at every edge or a corner? Like at this point, what is there? So a right angle, a corner, okay, an angle.
A vertex.
A vertex. Okay.
Vertices.
Yes, vertices. So we have vertices, and how many are they in number? How many are they if we count them?
8.
They're 8. Okay. So now within this three-dimensional geometry, we are going to be majorly interested in getting the length. So one of you said an angle. So which angle do these lines meet? At which angle do these lines meet? At which angle? At the right angle. Okay, hope that is right. So a right angle is 90 degrees. So each of these lines meet at 90 degrees. So everywhere they are meeting, it is 90 degrees. So one of our tasks that we shall be required to do is, for example, to find the length from one corner to another. For example, if we are told to find that, so what would we do to find such a length? Yes, your answer should keep coming like they have been coming in the chat. So how do we find, remember we said this is at right angle. So this one here. So if that is a right angle, so how are we going to get that length? Okay, for now we don't have figures, but if we put the figures, maybe, let me try to. So if this is a 6 centimeters, this is 8, and maybe this is 5. So how the one going upward? So how are we going to find? Okay, there is an answer in the chat. Let me come and read it briefly. So okay, Peter is saying, I think I can, but
No, sorry, that wasn't supposed to be for everyone.
Hey, okay. But you sent it to everyone. As if. Okay, so what we are going to do is to pick out this triangle here. We are going to pick triangle ABC. And it has a right angle in it. So when it has a right angle, how do we use that to find the missing side? If this is 90, this is 6, and this is 8. So which law do we use?
Pythagoras theorem.
Pythagoras theorem. So this is A, this is B, this is C. So we are going to say AB squared, so the short sides, the AB plus BC are equal to the longest side squared. So we say AB squared plus BC squared is equal to AC squared. Then we put in the values here. So this will be 6 squared plus 8 squared equal to AC squared. What is 6 squared?
36.
36. Then 8 squared. Peter, what is 8 squared?
$64.
64. So 36 plus 64.
100.
100.
100.
So what are we going to do on this step? We have AC squared is equal to 100. So what did we do?
We introduce the square root.
We introduce the square root. Do all of us agree to that?
Yes.
Okay. So we introduce the square root. So root of 100 is equal to root of this. And I guess here the square root dies with the square. And then we shall have AC giving us
10.
10. So this would be 10 centimeters. So AC would be equal to 10. Is that okay? Then suppose, so this one is for you to calculate and give me the answer. Okay. Suppose I want from A up to G. A to G. So we can still discuss. So how are we going to find AG?
Pardon?
So I've drawn on our box, our 3D figure, I've drawn a line from A up to G. So how are we going to find AG? Line length of AG?
I think it's going to reflect on AF.
AF is going to reflect on AF. Christine, what are we going to do to find AG? Okay, 10 squared plus 5 squared is equal to AG. Thank you. That is very good. So we had obtained our line AF. So we shall pick a triangle, which is, we shall pick a triangle ACG. And the ACG has a height of 5 here. And then we had calculated AC as 10. So we are going to get 10 squared plus 5 squared is equal to 8G squared. So we are going to have we are going to have 10 squared plus 5 squared is equal to 8G squared. So 10 squared, we had seen it is 100, and this is the 25 equal to 8G squared. So this will be 125 as given in the chart by Hope is equal to AG squared. Then here we shall take square root. So what is the root of 125? Okay, 11.101803. Thank you, Hope. Any other? Okay, this we are saying is going to be 11.1803. So should we add another line in our shape? And we see how to get its length. Okay. I've got one answer from Hope. Can I get the ideas of the rest? Okay, we could go back and add. I've added one from A up to F. I guess we are able to see it. So AF, how are we going to find AF? Okay, 8 squared plus 5 squared. That is great. Yes, Peter, AD plus FD. But they should be squared. AD squared plus FD. Yes, Hope says 8 squared plus 5 squared. That is great. So we shall have 8 squared plus 5 squared is equal to AF squared. Christine says that would be 89. And what would be the root of 89? $9.43. Thank you, Christine. 9.433, Peter. Thank you. 9.434 from Hope. Okay. So all those answers are correct. So that is how we get those different lines given such shape. So these shapes will always be in this form. So we can have, so this is the rectangular, then we can have a cuboid where all the sides are equal. So we still do the same for those sides. Then we can have a pyramid, we can have a cone. But the idea there is you join and form a right-angled triangle. Then you use that angled right-angled triangle after extracting it, you obtain, and then you apply Pythagoras theorem. So there you'll be able to find all the three sides. So let me stop sharing this for now, and we'll go back to our notes. So there is a video there who are talking about three-dimensional geometry that you can watch in your free time. And I guess equation of a straight line, so we don't need to find a straight line. The equation there, we shall find it in another topic. Equation of the plane, still we don't need that. The important formula, we don't need that. So what we are going to do next is to between a line and a plane. So maybe I'm going to, let me share something briefly about it. Then I will send you an assignment to do about it. So I think now these lines are many. Let me draw another one. So assuming our figure is like that, but this is not the best way it should look like. So if we are interested in getting the angle may be between the line. If we draw a line from there, and then we're interested in getting the angle between this line and the base. The base, which is this time I've not numbered it, but let me number it such that we can be able to tell the difference. So this is A, B, C, D, E, F, G, H. And now we are interested in finding the angle between this line and the base. So what we do is to connect a line, so to have a connection of a right angled triangle. So which other line can we draw on this shape to make a complete triangle with this line AF? Which line can we draw on our three-dimensional figure to make a right angled triangle with BF? So let me add it on the chart. So which line could that be? I'm waiting for the answers. Okay. BB from Christine. Thank you. The rest, please forward your answers. I'm waiting for them.
Same.
The same from Peter. Hope. Okay. So that is the line. So we shall add in a line BD. So from B up to D. And then now we shall have formed the right angled triangle, and the 90 degrees is just there at the what? Where the two are meeting. So the AF, the between DF and the DF and the DB are the ones at 90 degrees. So after that, we extract the triangle and have it aside. And then we shall be in position to say, first get a pen here. So if this is F, this is D, and this is B, so this will now be the angle that is required. So we can call it angle what? Theta. Then this is at 90 degrees. So remember, we can get this side here. So this side will be given. So our duty would be to find side DB from this. This one will also be meeting at 90 degrees. So that is briefly, but let us first make sure we have mastered how to find the distance between any two, the distance of connecting any 2 points on a 3D shape. Then after that, we shall be in position to find the angle between line and a plane, and then the angle between plane and plane. So I'm going to sit and organize some work. So I hope by the end of the day or by tomorrow morning, you will be receiving that work. Please attempt it and forward it for marking.
Pardon?
I was saying I'm going to prepare some work for you to do on finding the length of any 2 points joined, like what we have done in this first example here, what we have been doing here. So I'm going to send you some work concerning it, such that you are able to do it and then present it for marking. Okay. So I think possibly by tomorrow morning, you'll be receiving that work. Any questions? Okay, we shall meet again. I'm going to send that work. Please make sure you do it.